In Chapter 5, Section 2, Day 2 works more on polynomial functions. We're going to get more into the graphing part of it. A couple of things for you to take note on. Graphs have something called a turning point. A turning point occurs anytime that a graph is going up or down and changes direction. So if it's going up and then all of a sudden it starts going down, that's a turning point. Or if it's going down and all of a sudden starts going up, it's also a turning point. You can find the number of turning points by doing n minus 1. So that is written there for you to see, where n is the highest power that you have. The degree of a polynomial affects end behavior. End behavior is the behavior of the graph up or down on both the left end of the graph and the right end of the graph. So end behavior is probably easiest for you to understand via a chart. So if you take a look, they talk about the leading term. So the leading term always has a form of ax to the n, where a and n are numbers. I'm going to talk about positive and negative first. If the lead term is positive, that's the top, well, technically the middle row, that's this one right here, positive. And if that lead term is negative, that's this row. So you have to look at whether it's positive or negative first. And then you have to look at the degree. The degree is the little number in the air, like quadratic's degree is 2. Cubic's degree is 3. If that number in the air is even and a is positive, you're looking at up and up. If it's even and a is negative, it's down and down. You'll notice that when the degree is even, the end behavior matches on both sides. The end behavior doesn't match on both sides when the degree is odd. A positive odd is down and up, and a negative odd is up and down. You don't have to memorize this. This is something that can be given to you on tests or quizzes or homework, but it is something you definitely need to know how to read. So, number 1, determine the number of turning points for each equation. They're literally just asking you how many times it would turn. So at this point, you always look at the degree. The degree is 4, so it has 3 turning points. In letter B, the highest degree is 2. It has 1 turning point. Pause the video to complete the U-triads. So now we're going to talk about end behavior. They want you to consider the leading term of each polynomial function and describe the end behavior of the graph. So the first thing you need to do is determine which term should be leading term. That requires standard form. In standard form for letter A, the first term that should occur is this one. It's the highest power. The power there is a 3. That term is positive, and the power 3 is odd. I'll come back to this screen in 1 second, but I want to show you positive and odd. According to this chart, positive and odd has end behavior of down and up. So all you need to write is down and up. You're more than welcome to write the words out if you want, but you'll notice I use arrows, down and up. That end behavior means on the left-hand side, your graph is going to point down, and on the right-hand side, your graph will point up. Letter B, the lead term in letter B should be the highest power, which is this term right here. Negative 4x to the 4th would be leading. That is negative. Oh my goodness, if I could spell negative, I'm sorry. And the 4 in the air, not the 4 out front, the 4 in the air of that term says it's even. And again, I will come back to this slide in a second. I'm looking for negative and even. Negative and even is right here, so the end behavior is down and down. All you need to write are 2 arrows that are down. So on the left side, this graph would point down, and on the right side, it would point down. Take a moment, pause the video, complete the U-triads. So the reason we're talking about end behavior and turning points and roots in the first part of this section is so that we can generally sketch the graph. So they want you to put it in standard form, classify it by its degree, graph the polynomial, all that other stuff. So we're going to start first with the roots. I know that it's probably not something that you remember doing from a couple of lessons ago, but it's probably in your best interest to start there. In factored form, roots are easiest to get from that. My first root is 0 because of the x out front. My second one is a positive 2, and my third is a negative 3. So 0 and +2 and -3. Those are the places where your graph will cross or touch the x-axis. Up there. Okay, so next I'm going to do standard form. Remember, standard form, when we did this before, requires you to FOIL. So I'm going to do these two first, which means I'm going to keep this x out front. I'm going to FOIL x minus 2, x plus 3. I get x squared plus 3x minus 2x minus 6. And if I combine like terms, gives me x squared plus x minus 6. And now I'm just going to distribute the x in front to get x cubed plus x squared minus 6x. Throw a y in front to be pretty. This is standard form. We're going to do turning points first. Because this is a cubic, I said to classify it by its degree. Because it's a cubic, it has 2 turning points. I will abbreviate turning points with a TP. So 2 turning points. Now, its end behavior comes from that leading term. That leading term is an x cubed. It is both positive and odd. Positive and odd has an end behavior of down and up. Look back at that chart if you need it. So that means on the left side of my graph, it'll point down, and on the right side, it'll point up. So all you have to do is connect the dots. So I usually start on the left, go through my first point, turn to go back to the second one, and then turn again to go back to the third. I always double check that I have the right number of turning points. On a graph, turning points look like mountains and valleys. I have a mountain up here and a valley down there. You don't have to put asterisks on your graph just so you can see them. And that's 2. And I expected 2 turning points. So I just want to read back through the directions one more time, make sure I got everything. Let's see, they wanted end behavior, I did that. Turning points, did that. Put it in standard form, classified it by its degree, and graphed it. Should be good. That's it. All right, letter B. I'm going to do roots first. That's the easiest. My roots are +1 with a multiplicity of 2, a little 2 in the air, and I also have -3. Okay, +1 occurs there, and -3 occurs there. Now that +1 with its multiplicity means it will turn there. That's important. It won't cross, it'll turn. All right, let's do standard form next. In this standard form, I'm going to leave the negative out front, and I'm actually not really advantageous in this one at all. I'm going to actually write this out first. That means I have 2 copies of x minus 1, and recopy the x plus 3. So I'm going to take care of the x minus 1 first. I get x squared minus x plus 1. And don't forget to recopy anything you haven't dealt with. If I pretty up the red stuff, I get x squared minus 2x plus 1. Remember, the order in which you choose to do this doesn't matter. I'm going to do the 3 by 2 next, so I'm going to keep that negative out front. I haven't done anything with that yet. I get x squared, or no, not x squared, sorry. X cubed plus 3x squared minus 2x squared minus 6x plus x plus 3. That was a pretty big distribution. I'm going to pretty that up before I give my negative. X cubed gives me plus x squared, and then minus 5x plus 3. So if I distribute the negative, my final standard form is y equals -x cubed minus x squared plus 5x minus 3. All right, because that leading term is a cubic, I needed that too, it's a cubic, it means it will have 2 turning points. That lead term is a negative and an odd. A negative and an odd has end behavior of up and down. Negative and odd, check that chart, is end behavior of up on the left and down on the right. So above my left endpoint, I put an up arrow. Below my right endpoint, I put a down arrow. Now, this is tricky. Remember, I told you, because that +1 has a multiplicity, it's going to turn there. So start following, but instead of crossing at 1, turn at 1. You're going to notice, and this kind of bothers me a little bit, so I'm going to fix this side over here. Instead of coming up so harshly, go down a little bit and then do that, just so it looks a little better. The mountains and valleys that you have, your actual turning points here, you're not going to know how high or how low they go at this point. Just don't exaggerate them too much. Also, don't make them too small. And just kind of put a fairly equal mountain or valley there. That's not something you'll do in Algebra 2. It is something that can be done for sure to determine, I'm talking on the graph right now about a point that happens like right in here. You don't know how low that goes. It is something you can find, but that's not an Algebra 2 thing. So for right now, I'm most concerned about where it crosses and the end behavior and number of turning points. Pause the video to do the U-try it. So the last one actually isn't a you try it because it's already given to you in standard form. So you have to kind of go backwards to get the root. I'm going to pull a negative x out, which leaves me with x squared minus x minus 3. And then to factor the x squared minus x minus 3, two numbers that multiply to negative 3 and add to negative 1, oh boy, aren't a thing. I'm assuming this is a typo. I'm actually going to change that to a 2. This should be an x minus 2, x plus 1. I believe that was a typo. Which means that my roots here occur at 0, 2, and negative 1. 0, 2, and negative 1. This was a cubic. You can look back at the standard form that they gave you originally. It is a cubic whose lead term is negative and odd. So my end behavior is up and down with 2 turning points. Cubics have 2 turning points. So on the left it'll go up, on the right it'll go down. So just trace and cross everywhere that you have a green dot, or in your case just a root. And that's it.